Hi, welcome back. Today I'll be showing how to upload aerial imagery into ImageBreed. By aerial imagery, I mean either complete images from above, such as this tray experiment. It can be a color image or could be a spectral image. And aerial imagery can also be orthomosaics. So these are stitched orthomosaic products of many collected images. Here I have a MicaSense 5-channel orthomosaic. So you have the blue, the green, the red, the near infrared, and the red edge spectra in individual images. So these are the types of images we can upload. I have 2 field experiments loaded into the system. If I open up the first, we can see for field trial 1, we have a planting date set. And here we see it was 5 accessions completely randomized into 4 blocks. If I open up the second field experiment, has a planting date set also. You can change it by going into here, say August 2nd. And here we had 5 sessions completely randomized into 5 blocks. Now, if I go to manage aerial imagery, and I go to upload imagery, we see a workflow, and we have the example data here. The raw captures and the panel images, those example data sets are for generating orthomosaics in ImageBreed using OpenDroneMap. I have a previous video that shows how to do that. For this video, the previously stitched orthomosaic data set is what I'm showing here on the screen. So if I go to upload a single imaging event, I can select either one or several field trials. So in practice, when you fly a drone, you often capture many different field experiments in a given imaging event. And so even though in this image there was only one, for demonstration purposes, I'll select both field trial 1 and field trial 2. Then here, I give a date for the imaging event. I'll say December 8th, and you can give an hour as well. It asks, is this a greenhouse, growth chamber, or fixed camera rig? And in this case, it's not, because we used a drone to collect this imagery. In this color camera case, this would be a fixed camera rig. But for this demo, we'll use the MicaSense camera, and so no. Here, then, it generates unique names for the imaging event. We have to specify whether it was medium or low resolution. These are medium to high. The sensor type, so you can select the MicaSense 5-channel. You can select color cameras, and these are kind of single spectral image types. For this, I'll select the MicaSense. We have to select the imaging vehicle. So I need to add a new one here. I'll say I was using a Vision aerial switchblade drone. Just testing. Sorry, submit. And so now I can select that as my imaging vehicle. And for a description, you can specify information about how the orthomosaic was produced, or so I'll say it was from Pix4D. And you can also include some weather information or other information about the imaging event. On step 4, you select whether you're uploading orthomosaics or whether you want OpenDroneMap to create the orthomosaic for you. In a previous video, I showed how to use OpenDroneMap. In this one, I'll show using previously stitched orthomosaics. Here I select the number of spectral bands. So it's 5 because I have 5, the MicaSense 5 channel. In this step, I give a description. So I'll just say orthomosaics. It pre-populates the image types here, so blue. And then I select the image. So B1 is blue. I do the same thing for green, B2, then red, give a description and select the image. B4 is the near infrared, and then B5 is the red edge. So I finish and submit. Was successfully uploaded. And so now it shows up as an imaging event under each field experiment. But since each field experiment had a different planting date, for instance, the days after planting for this imaging event will be different. So it was 97 days for field trial 1 and 128 days for field trial 2. Both field trials are pointing to the same images in the system. So the same images that were uploaded, and that saves some disk space by not duplicating the imagery. We can view the uploaded imagery by spectra here. So this is the near infrared, this is the red. I can download the original high-res image. And from here, the next step is to run the standard process, and that will allow us to draw the plot polygons and then extract phenotypes. So stay tuned, and thanks for watching.